NASA has one of the largest concentrations of aerospace ground testing facilities in the nation. Our mission is to drive the advancements of wind tunnels and enable NASA's success. How we do this is by delivering timely and cost-effective data that will transform the design of the next generation of aircraft, spacecraft, or planetary entry vehicle. Numerous successful test campaigns were achieved in 2022 that will ultimately drive changes in the aerospace landscape.
Beginning with the Aeronautics Research Mission Directorate test, at Glenn's 8x6 supersonic wind tunnel, there's the X-59 Air Data Probe 2 reentry test. Also at Glenn's 8x6 supersonic wind tunnel is the Low Boom Flight Demonstrator LBFD Sonic Boom test.
The wind tunnel test is the first time we are getting experimental data in the near field on the X-59. It is also the first time we're getting experimental data on a closed low boom design configuration that we can use for CFD validation. The test data showed excellent agreement with predictions, which provided us confidence in the low sonic thump shaping of the X-59.
Also at Ames, at the Unitary Planned Wind Tunnel, was the Transonic Truss Brace Wing Test.
The tests are just critical to us being able to evolve our research because of the data that we obtain from the tests. For example, we have pressure data, surface pressure data, many chord rise rows of pressure data on the wing, and definitely in the area where, again, the strut attaches to the wing. And so that provides a very good insight into the aerodynamic characteristics of the wing and of the design.
Also at Langley, in the Transonic Dynamics Tunnel, is another amazing and daring project, the Mars Sample Return Mission. A sample return lander would land, bringing a small rocket on which the samples collected by Perseverance would be loaded. 2 Ingenuity-like helicopters would provide a secondary capability to retrieve samples on the surface of Mars.
AETC has successfully sustained operations of all its wind tunnels, mostly built in the 1950s. Thanks to our stellar workforce, we were successful in targeting and mitigating key tunnel systems before major repairs and failures occurred, thus maintaining our risk-to-test posture. In 2022, all tunnels were operational or in a scheduled maintenance mode. Here are a few investments made in 2022.
The Ames 11-foot Unitary Planned Wind Tunnel drive replacement. The 3-stage compressor aluminum rotor blades exceeded design life and were replaced with a new set. AETC contributed to this effort by investing in the development of an improved blade stress measurement system, including modifications to re-stagger row 1 blades for better performance. Additional repairs made include the failing National Transonic Facility near-side plenum door operating system at Langley Research Center. The 24,000-pound door was lifted and tilted into the test section for extensive modification work that included correcting the alignment of the door and installing a new rail system.
AETC continues to invest in new capabilities that ensure wind tunnels remain relevant to our customers. These investments are targeted against novel technologies that provide higher quality data, they can meet new customer-required tunnel conditions, or improve operational efficiencies.
AETC is investing in new capabilities as a means of better meeting mission requirements. The long-duration Mach 6 testing, which addresses both the life cycle limit and environment simulation needs in the hypersonic regime. AETC is also meeting mission requirements to reduce costs through test optimization, such as unsteady pressure-sensitive paint, which provides real-time resolution pressure data across the greater model surface. Which brings you to my project.
Hi, my name is Nettie Roosboom. I'm the PI of the Unsteady Pressure-Sensitive Paint Capability Challenge under AETC. Several customers came to me with the steady-state pressure-sensitive paint and said, we need unsteady PSP. We need to be able to measure these surface pressures at a higher resolution. So the future is unsteady, and what that means is All the vehicles that we're designing now are more advanced. They don't follow the models that we understood before. And so the next major challenge for the broad field of aerosciences is understanding these unsteady flows. And these unsteady flows really limit the performance. They dictate the structural requirements for these models and for these vehicles. And so to understand unsteady flow, you have to measure the surface pressure, the unsteady surface pressure distribution.
AETC is also investing in the Common Research Model High-Lift Certification by Analysis, which applies robust testing methodologies to reduce flight certification testing in the low-speed, high-lift flight envelope, as well as CFD evaluation at high supersonic speeds, determining CFD accuracy and costs relative to testing.
Looking forward, we will undertake bold and transformative changes, one being digitally transforming the management and operations of our wind tunnels. This transformation will ensure faster and more accessible access to customer data through a centralized data portal. In addition, near real-time determination of tunnel performance and value will be achieved, allowing data to drive business outcomes more pragmatically and effectively. The future is looking good. I hope we have made clear how AETC is continuing its tradition of excellence while constantly looking to improve itself to be able to provide both an efficient and expansive set of services to NASA, as well as our other partners. Thank you.